This biochem topic is tested on every exam.
Michaelis-Menten kinetic data for an enzyme in the presence and absence of an inhibitor is shown. What statement about the mechanism for inhibitor binding is supported by the data in the table? And the inhibitor binds which of these? So let's look at the data. So first of all, the inhibitor is not present here. So this is what we need to compare the kinetics of the inhibitor to. So when there's no inhibitor, the Vmax is 12 and the Km is 0.6. But notice that when you add the inhibitor, the Vmax doesn't change, but the Km increases. So this is consistent with a competitive inhibitor. The competitive inhibitor doesn't change the Vmax, but it increases the apparent Km. And remember that a competitive inhibitor is a substrate analog. So it binds non-covalently to the active site specifically, right? So A is wrong because this is talking about some sort of allosteric inhibitor like an uncompetitive or a mixed inhibitor, okay? That would be binding to an allosteric site, so that's wrong. And then B, within the active site instead of the substrate, that is correct, okay? Because a competitive inhibitor is competing with the substrate for the active site and binds the active site. And then C, at a site separate from the active site is wrong. And then D, within the active site after the substrate binds, that's wrong because the competitive inhibitor is occupying the active site instead of the substrate. So if the substrate has bound, the competitive inhibitor can't bind. And if the competitive inhibitor binds, the substrate can't bind. So they compete for the site, they don't share it, right? So B is the best answer.